Trigonometric identities. Today we discuss about trigonometric identities. Class 10 CBSE board. 𝗲𝗶𝗶𝗀 chapter number exercise 13b. 𝗲𝗶𝗶𝗀 exercise 13b. Let's start the problem. First problem. If a cos theta plus b sin theta is equal to m and a sin theta minus b cos theta is equal to n. So these are given. Then prove that m square plus n square is equal to a square plus b square. So first m is equal to, right, a cos theta plus b sin theta. Therefore m square, squaring both sides, so m square is equal to a cos theta plus b sin theta, its whole square, because in left hand side m square is there, so first we get the m square. Similarly, given n is equal to a sin theta minus b cos theta, therefore n square, by squaring both sides, n square is equal to a sin theta minus b cos theta, its whole square. Now from left hand side is equal to m square plus n square. Now put the value of m square. M square already it's given, so we write a cos theta plus b sin theta, its whole square, plus n square means a sin theta minus b cos theta, its whole square. So simply it is x plus y, its whole square, and it is x minus y, its whole square. So we may write here a square cos square theta plus 2ab sin theta cos theta plus b square sin square theta. Now this one is compared as x minus y, its whole square, so x means a square sin square theta minus 2ab sin theta cos theta plus b square cos square theta. Fine. Now we have to prove a square plus b square. So here a square cos square theta and b square cos square theta. So what we will do, and b square sin square theta plus a square sin square theta, and these two terms are cancel out, plus 2ab sin theta cos theta minus 2ab sin theta cos theta. Fine. So we may write it as, take common a square, so we get cos square theta plus here it is sin square theta, and take common b square, so here it is sin square theta, plus here it is cos square theta. Now we know sin square theta plus cos square theta is equal to 1, so we may write a square into 1 plus here also same b square into 1, so a square plus b square right hand side. Proved. Now problem number 2. If x is equal to a sec theta plus b tan theta and y is equal to a tan theta plus b sec theta, then prove that x square minus y square is equal to a square minus b square. Almost the same problem. Here it is given x. So first we find the x square. So given that x is equal to a sec theta plus b tan theta. So squaring both sides, we may get x square is equal to a sec theta plus b tan theta, its whole square, and y is equal to a tan theta plus b sec theta. Therefore, squaring both sides, y square is equal to a tan theta plus b sec theta is whole square. Now, we have to prove x square minus y square is equal to a square minus b square. So left hand side is equal to x square minus y square. So what is x square? This one is a sec theta plus b tan theta, its whole square, minus a tan theta plus b sec theta, its whole square. So if we expand this whole square, then we will get a square sec square theta plus b square tan square theta plus 2ab sec theta tan theta minus, now it is a square tan square theta plus 2ab sec theta tan theta plus b square sec square theta. Okay. Now a square sec square theta plus b square tan square theta plus 2ab sec theta tan theta minus, now remove the bracket, so it will be minus a square tan square theta minus 2ab sec theta tan theta, fine, minus b square sec square theta, fine. So here it is plus 2ab sec theta tan theta and it is minus 2ab sec theta tan theta is cancelled out. Then what we will get? A square sec square theta plus b square tan square theta, and here it is minus a square tan square theta and minus b square sec square theta. But we have to prove a square minus b square, fine. So when we have to prove it a square minus b square, then we must take common of a square minus b square. Okay, how it is possible? So we may here we may take common sec square theta, and here sec square theta. So sec square theta is common, so we get a square minus b square. Similarly, we take common, here it is okay, fine, tan square theta, so it is b square minus a square. Now from these two terms, a square minus b square and b square minus a square, so we can arrange it by taking a minus common. So we may write sec square theta into a square minus b square minus a square minus b square tan square theta, fine. So a square minus b square is common here from both the term. So a square minus b square take common. So we may write sec squared theta minus tan squared theta. And sec squared theta minus tan squared theta is equal to 1. So a square minus b square into 1. Therefore, it is a square minus b square. Fine. Very simple sum. Just you have to expand the whole square and then take common. Now the next sum. Here it is given that x by a sin theta minus y by b cos theta is equal to 1, and here it is x by a cos theta plus y by b sin theta is equal to 1. Prove that x square by a square plus y square by b square is equal to 2. We have to prove. Okay, so how we can solve it? First, it is given x by a sin theta minus y by b cos theta is equal to 1. So it is given. So we may write x by a sin theta minus y by b cos theta is equal to 1. So squaring both sides, we may write x by a sin theta minus y by b cos theta, its whole square is equal to 1 square, that means 1. Now if we expand this one, this whole square, so what we may write? We may write x square by a square sin square theta minus 2 into xy by ab sin theta cos theta plus y square by b square cos square theta is equal to 1. So we may write this is the equation number 1. Now from another given, that is x by a cos theta plus y by b sin theta is equal to 1. Now squaring both sides, we may write x by a cos theta plus y by b sin theta, its whole square is equal to 1 square. So we can expand this whole square term as like x square by a square cos square theta plus 2xy by ab sin theta cos theta plus y square by b square sin square theta is equal to 1. This is equation number 2. Now if we add equation number 1 and equation number 2, then what we will get? Add equation number 1 and equation number 2. So we may write here x square by a square sin square theta plus cos square theta. Here it is x square by a square sin square theta, here it is x square by a square cos square theta. So we take common x square by a square, so sin square theta plus cos square theta. Here this term and this term are opposite in sign, so these have to cancel out. Same, minus 2xy by ab sin theta cos theta, here it is plus 2xy by ab sin theta cos theta. So these two are cancelled out, and we will get here by y square, by taking common y square by b square sin square theta plus cos square theta is equal to 1 plus 1 2. So sin square theta plus cos square theta is equal to 1. So we may write, so x square by a square plus y square by b square is equal to 2 root x is equal to a cos cube theta plus and y is equal to b sin cube theta. Now prove that this one. So we may write here x is equal to a cos cube theta. So x by a, just take a into the denominator of left side, so is equal to cos cube theta. Fine. Then y is equal to b sin theta. Now y by b is equal to sin theta. Similarly, so from left hand side, x by a whole to the power 2 by 3 plus y by b whole to the power 2 by 3 equals to, what may write, x by a is equal to cos cube theta. So we may write cos cube theta whole 2 by 3, y by b is equal to sin theta. So put here sin theta whole 2 by 3. Now this 3 and these 3 cancel out, so we may write cos squared theta, this sin cube theta, sorry, it is sin cube theta. So this 3 and this 3 is also cancel out, so this one is 1. Okay. Now the next problem is x is equal to b sec cube theta and y is equal to a tan cube theta. Then prove that this one. So we may write from the given x is equal to b sec cube theta. So x by b is equal to sec cube theta. Similarly, y is equal to a tan cube theta. So y by a is equal to tan cube theta. Fine. Now left hand side, x by b whole to the power 2 by 3 minus y by a whole to the power 2 by 3. Just we find out these two terms, then just put the values. Okay. So x by b is equal to sec cube theta. Just put sec cube theta. Then whole 2 by 3 minus tan cube theta whole 2 by 3. These three cancel out, these three cancel out, so we may write sec squared theta minus tan squared theta, which is equal to 1. Proved. Now next problem. If tan theta plus sin theta is equal to m and tan theta minus sin theta is equal to n, then prove that m square minus n squared whole square is equal to 16 mm. So m is equal to tan theta plus sin theta. So squaring both sides, we may write m square is equal to tan theta plus sin theta its whole square, and n is equal to tan theta minus sin theta. So squaring both sides, we may write n square is equal to tan theta minus sin theta its whole square. So from left hand side, and another term we may find it here, that is mn. What is mn? As it will be required. So mn is equal to m is equal to tan theta plus sin theta and n is equal to tan theta minus sin theta. So we may write here tan squared theta minus sin squared theta. Simple. X plus y into x minus y. X square minus y square. Now from left hand side, what is m square minus n square, then its whole square. So m square is this one, tan theta plus sin theta its whole square. This is m square. Okay. minus n square, that is tan theta minus sin theta, its whole square, then its whole square. Fine. So if we expand this one, so we may write tan square theta plus 2 tan theta sin theta plus sin square theta minus tan square theta minus a minus beta whole square. So minus 2a beta minus minus plus, so it is plus 2 tan theta sin theta plus sin square theta, so it will be minus sin square theta whole square. So tan square theta and tan square theta cancel out, sin square theta and sin square theta cancel out. So we get 2 tan theta sin theta, here also 2 tan theta, 4 tan theta sin theta, its whole square. Now so 4 tan theta sin theta, its whole square, so it is 16 tan square theta sin square theta. But we have to prove 16 m into n. So here we may write mn is equal to tan square theta minus sin square theta, and we get that is tan square theta sin square theta. Fine. So from here we may write tan square theta is equal to sin square theta by cos square theta. So sin square theta by cos square theta minus sin square theta. So if we take common sin square theta, so 1 by cos square theta, that is sec square theta minus 1. So it is sin square theta into tan square theta. So here we may put the value 16 mn. So mn is equal to sin square theta into tan square theta. So we may write here is equal to 16 mn. Fine. Once again I am telling you mn is equal to tan theta plus sin theta and tan theta minus sin theta. So x plus y into x minus y, so x square minus y square, that is tan square theta minus sin square theta. Now tan square theta is we may write sin square theta by cos square theta. So sin square theta by cos square theta minus sin square theta. Now take common sin square theta. Sin square theta is common, so this 1 by cos square theta. 1 by cos square theta means sec square theta. Sec square theta minus 1. So sec square theta minus 1 is equal to tan square theta. So tan sin square theta, tan square theta. So sin square theta, tan square theta is equal to mn. So here sin square theta, tan square theta. So we put the value mn. So it is equal to right hand side. So it is proved. Next problem. If cot theta plus tan theta is equal to m, then cot theta sec theta minus cos theta is equal to n, then n square n whole to the power 2 by 3 minus n square whole to the power 2 by 3 is equal to n. So given m is equal to cot theta plus tan theta. Fine. Now we may write here cot theta is equal to 1 by tan theta. So 1 by tan theta plus tan theta. So tan theta, if we take LCM, tan theta 1 plus tan square theta. Okay. Then we may write here 1 plus tan square theta is equal to sec square theta by tan theta. So sec square theta is equal to 1 by cos square theta, 1 by cos square theta, tan theta is sin theta by cos theta, so cos theta by sin theta, so it is 1 upon sin theta cos theta. So it is equal to m. Okay. Similarly, n is equal to sec theta minus cos theta. So similarly, we may write here also sec theta minus cos theta. So sec theta is equal to 1 upon cos theta minus cos theta. So 1 minus cos squared theta by cos theta. LCM is cos theta. So 1 minus cos squared theta, that is equal to sin squared theta. As sin squared theta plus cos squared theta is equal to 1. So 1 minus cos squared theta is equal to sin squared theta by cos theta. Okay, so it is n. And another one term we will evaluate, that is mn. So m is equal to 1 by sin theta cos theta, 1 by sin theta cos theta, and n is equal to sin squared theta by cos theta. So mn is equal to this one. Okay, now in left hand side we have m square n whole to the power 2 by 3. So what about m square n? So m square n is equal to 1 by sin squared theta cos squared theta into sin squared theta by cos theta. So sin squared theta cancel out. So 1 by cos cube theta, that is m square n. Similarly, mn square. So m is equal to 1 by sin theta cos theta into n square means sin to the power 4 theta by cos squared theta. So 1 sin theta is cancelled out. So sin cube theta by cos cube theta. Fine. Now from left hand side, m square n whole to the power 2 by 3 minus mn square whole to the power 2 by 3. So m square n, this one is 1 upon cos cube theta whole by 2 by 3 minus mn square sin cube theta by cos cube theta whole upon 2 by 3. Fine. So what we may write? So we may write here, it is sec cube theta 2 by 3 minus, it is tan cube theta sin 2 by 3. So these three cancel out, these three cancel out. So this is sec squared theta minus tan squared theta. So this is equal to 1, this is equal to right hand side. Proved. Okay. Now the next problem. Cosec theta minus sin theta is equal to a cube and sec theta minus cos theta is equal to a b cube. Then prove that a square b square into a square plus b square is equal to 1. So from given, that is cosec theta minus sin theta is equal to a cube. So from this, what we may write, that is cosec theta is equal to 1 by sin theta, this into 1 by sin theta minus sin theta is equal to a cube. So 1 minus sin squared theta by sin theta is equal to a cube. Okay, so we may write 1 minus sin squared theta is equal to cos squared theta. So cos squared theta by sin theta is equal to a cube. Okay, cos squared theta by sin theta is equal to a cube. Similarly, sec theta minus cos theta is equal to b cube. So 1 by cos theta minus cos theta is equal to b cube. So 1 minus cos squared theta by cos theta, simple LCM is cos theta, is equal to b cube. So 1 minus cos square theta is equal to sin square theta by cos theta is equal to b cube. So we evaluate the value of a cube and b cube. Now come to the left hand side of this problem. So left hand side is equal to a square b square into a square plus b square. Fine. So what we may write here? Just multiply. So we may write a to the power 4 b square plus a b to the a square b to the power 4. Fine. Then we may write here, we take common a cube b cube. So a cube b cube, if we take common a cube b cube, so a by b plus b by a. We take common a to the power 4 a cube, that is a, and there is b square, but we have taken b cube, so it is divided by b. So a by b. Similarly, it is a square is here, and we take common a cube, so it is by a, and b4 b to the power 4 b cube is common, so b by a. Fine. Now what is a cube b cube? Now what separately we find out what is a cube b cube. A cube b cube is equal to cos square theta by sin theta into b cube is equal to sin square theta by cos theta. So it is simple sin theta cos theta. Fine. So it is simple sin theta cos theta. Now we may write here a cube means cos square theta. Let's put the value by sin theta into b cube means sin square theta by cos theta, and a cube b cube means a cube b cube means sin theta by cos theta. So write here directly sin theta cos theta, sin theta cos theta into a by b. What is a by b? What is a by b? That is a cube is equal to cos square theta by sin theta, and b cube is equal to sin square theta by cos theta. Now separately we find a cube by b cube is equal to cos square theta by sin theta into by b cube, so cos theta sin square theta. Fine. So sin square theta by cos square theta. Sorry, this is let's reverse, cos theta by sin square theta. So it is cos cube theta by sin cube theta. So a by b is equal to cos theta by sin theta. A cube by b cube is equal to cos cube theta by sin cube theta. Then a by b is equal to cos theta by sin theta. So it is cos theta by sin theta plus it is sin theta by cos theta. Just reverse. So sin theta cos theta into LCM is sin theta cos theta. So cos square theta plus sin square theta. So these two are cancelled out. So cos square theta plus sin square theta is equal to 1. So right hand side proved. Simple. So first we evaluate the value of, it is given cosec cube theta minus sin theta is equal to a cube. So from here just we simplify, we find a cube. Similarly we find b cube. Then a cube into b cube, just we multiply and we get a sin theta cos theta, and a cube by b cube, then we get cos theta by sin theta. Now left hand side just we multiply, then take a cube b cube common. So a cube b cube into a by b plus b by a. Now a cube b cube is equal to sin theta cos theta. Just put a by b is equal to cos theta by sin theta, and b by is equal to just reverse sin theta by cos theta. Now LCM is sin theta cos theta. Now cos square theta plus sin square theta, these two are cancelled out, so it is 1. Fine.